Hello everyone and welcome to the second part of the tutorial on how to work with 3D models in model particle fluid. Here we will be looking at how to create a rotation and apply it to a model. So first things first, rotation will rotate the model around its center. So that's pretty straightforward. Next, the three transformation that you can set, which is rotation, scale and position, will be applied in the following order. First, the model will be scaled, then the model will be rotated, and lastly, the center of the model will be moved to the position that you set. Now, this is important to know because, for example, you cannot scale the model after you already rotated. Which is a little bit unfortunate because sometimes you could use that, but it's just not supported in the version that I've created. And lastly, most importantly, what are the ways to actually create a rotation? Well, there are three ways, and we will take a look at all of them. So we will start with Euler angles. This is a pretty simple method. You just specify three angles. First angle is for rotation left and right. Second angle is rotation up and down. And third angle will spin the model around the model's x-axis. And these three rotations will be applied in that order, and it is an easy way to create a rotation. So let me show you what I mean. Here I have 8 dogs. You can see I have made the model myself because it's really crappy. But here at the left button, we will finally see what this does. So this rotates the dogs left and right. This rotates them up and down, and this just spins them around. Now as you can see these three at the top, this dog gets only rotated left and right. This dog only rotates up and down. And this dog only spins. And this dog is here just to show you what the default dog without rotation looks like. However, these dogs here at the bottom, they actually stack the rotations on top of each other. So all three of them rotate left and right. And these two on top of rotating left and right also rotate up and down. So you can see that if I reset everything and I want to rotate it to the left a little bit, and then I want to rotate up, then I rotate like this and the model goes up. And lastly, I want to spin it, so I spin like this and the model spins around. So this is a very simple way to create a rotation. Here I have an example of a missile. Hang on, this let's move it around so that you can see better. Here is an example of a missile that has the left and right rotation set the same throughout the launch. The up and down rotation changes as it goes along the way, and it also spins on top of it. So you can set it really easily with just three angles like this. So up and down like this, and then spin. Now let's take a look at the code. It's relatively simple. So I have it here. It's called Doggos. And here I load the 8 models by just creating the name and using the name both as the name of the object and as the name of the variable. Then I just calculate the XY position and set it. So this is to set the dogs. And here I use the create rotation Euler, and as you see on the first row, each angle was applied separately. So again, this one for left and right, this one for up and down, and this one for spinning. And on the bottom row, the angles are combined like this, so you can see the progression. But I already showed you that, so no need to show you again, just how the code looks. And you can see it's really simple. So let's continue with the presentation. Here you can see some images. Now these axes with the pointer, this is the global coordinate system, and the ones without the pointer is the part of the model. That is the model's coordinate system that is rotating together with the model. Now this will become important later, but for now let's just look at if you call A B C, then A will rotate it like this, B will rotate it up like this, and C will spin it around. Now, to the analogy of this would be to just set an angle. That in 2D you just need one angle. So this would be this angle A. It is the same. It just starts going right, and then it rotates it this way. So the A angle is same in 2D as in 3D. So that's pretty neat as well. So let's go on to the next one. This one is pretty simple as well. It's called look at target, and I'll start with the image this time. You just give it a vector, just x, y, z, and this is where the vector points in space, and if you apply the rotation, the model will look towards that position in space. So it's actually pretty simple. Again, just x, y, z, create rotation target. Now here I have this car that is using that, except, hang on, let me, yeah, I was playing around with it, and yeah, I want to get rid of this and like this for now. Nice, so this is what I wanted. So this car is always trying to look at this core here in the air. So if I move the car around, yeah, the mouse detection doesn't work very well with the 3D. Oh no, what is? Yeah, you can see it tries to look at the core. Now let me move it up here as well, and again you can see the car is looking at the core. Now let me move it right under it. So you see it is rotated so it looks towards the core. Now the way you do it is you call this create rotation target, and you the parameter you pass to it is just the relative position of the target to the core. So here I take the target coordinates, which I have set here, and then I take the current pixel coordinates of the core and 0, which creates a position of the core in 3D, and then I called a sub3 command, which will subtract two 3D positions from each other, so it will be this one minus this one. Oh, misclick. Minus this one, and that will be the relative position to the target from the model that I will just put into create rotation target, and then the whole result will be applied to the car model. And that's how you use this approach. So let's read what I have prepared here. Yes, given a vector returns a rotation that makes the model look at that vector. So that we saw. And what's interesting is that the up direction of the model tries to stay the same unless you specify your own. So what this means is, as I'm moving the car around, hang on, how do I move it? You can see that I never see the bottom of the car, and I never see the car of the sides of the car. So it's like rotating left and right and up or down, but it never spins the car like this. So that's important, and if you do want to spin the car like this, you can specify your own up vector, as it says here. And how do you do that? Well, let's say that I want the y vector, I mean the up vector, to be rotated towards positive y, which is in this direction. So how does that look? Compile. You can now see that the top of the car is being rotated towards this direction. Now, why would you want to do this? Well, let's say there's a black hole over here, or over here somewhere, whatever, and then the car just goes around the black hole, and you want the top of the model to face towards the black hole that is trying to suck it in as the model is trying to escape. That, I guess, is one scenario where I would find this useful personally. But other than that, you will probably just want to use this without the up vector, and the model will just face always upwards like that. So that's the set rotation target. Good to looking at target, yes. And lastly, any rotation can be created like this if you use the up variant. So that is always a nice thing to know. So yeah, Just let's, yeah, we already saw the image, just set the point. Remember, if you want to go upwards, you need negative z, and this will return a rotation that makes the model look at that point. Now, a 2D comparison to that is if you have the xy coordinate of where you want to look at, you just need to call yx 8 and 2, and that will be the angle that you need to set. So this is like the 2D comparison. So let's move on. Now the third way to create a rotation is to create a rotation around an axis. Now the way this works, why is this long key? Just shortly. The way this works is, let me actually show you. Here I have prepared this doc to be special because these three numbers will move this yellow arrow for me around in space. So what happens when I change this angle? Well, this dock will get rotated around this yellow angle. So if I look from this direction, the dock should rotate like this. And if I look from this direction, then you should see that it is rotating around the yellow arrow. So this is like a general way to create a rotation. And the way you do it is you just specify the axis that you want to spin around. So this yellow arrow here is the axis that you want to spin around, and then you specify the angle, how much radians you want to spin around that axis. And to determine which way you will spin, you use the left hand rule. Why? Because particle fleet uses a left hand system. Now how do you tell that this is a left hand system? I have prepared the coordinate curves here. Well, if you have the x, y and z, and you take one of them, let's say x, and then you want the y to rotate towards the z. Now if you grab the x-axis with your left hand, let's imagine that this is made out of like 3 steel pipes, and you actually grab the x-axis with your left hand so that your thumb is pointing in the direction of the axis. Then your fingers, if you rotate it in the direction of your fingers, the y-axis would move towards the z-axis, if you can imagine that. Now because this is true for your left hand, if you try it with your right hand, and again thumb in this direction, and you spin it in the direction of your other fingers, the z-axis would actually move towards y. So it wouldn't work out. You want the y-axis to move towards z-axis, and if it works for your left hand, then this is a left-handed system. If the x-axis was going this way, then it would work with your right hand, so that would be a right-hand system. But this is a left-hand system. Now why is this important? Because the same rule applies when you are rotating around an axis. Just imagine grabbing the axis with your left hand and your thumb going in the direction of the axis, and then the rest of the fingers show the direction of the rotation. So if I use positive angle here, it will actually spin like this. So the y will start to go downwards and the x will go up like this. So you can see that is the case. Now the worst case scenario, if you don't want to remember this, you just try it 50-50, and if you fail, you just negate the angle. So that works as well. So this is a rotation around an axis. So yeah, this is what I was explaining, how to use the left hand rule. And of course, negative angle will rotate in the opposite direction. That makes sense. And also a fun fact, any rotation is in fact a rotation around an axis. So an example, here you specify a point, then x, y, z, and the axis will go from the model center towards the point and onward, and then the angle will rotate around that axis like so. So let's look at some examples. First we have how to create the rotation with the Euler angles. So it needs angles in radians, so if you want them in degrees, then don't forget to convert them. So this would rotate the model left 60 degrees, then up 30 degrees, and it wouldn't spin it. So this is next one is how to create a target rotation. This is the one from the hang on. This is the one from the example. This one 10 8 minus 5. Again, it would create a rotation like this. Next one is the create rotation target 2, which takes the up vector as well. And if you want the same to be the same as this one, you just set the default up vector, which in this case is negative z. So that would be 0, 0, minus 1. And lastly, rotation around axis. Now, if you rotate around the negative z-axis, so let's try it out. Again, let's reset everything. And how do I rotate again? Around negative z-axis. Oh, this is positive z. I want negative z. Then oh, my bad. Well, I wanted to say that this will rotate it 30 degrees to the left. But actually around positive z. It will rotate it 30 degrees to the left. Because I thought that negative z is going downwards. Because I made a mistake. But around positive z, if you rotate by an angle, then it will spin the model to the left by that angle. So that was what I was saying to do in this example. And all these functions return a rotation, that is actual object that you can put on the stack. You can save it into variable. You can put it in a list. You can duplicate it. You can even set this variable into another core because because it's actually just a list with 4 numbers in it. But that's just a detail. It's just a value that you can manipulate like any other. And to set the rotation into a model, you just use the model variable, then the rotation that you created, and then set model rotation. Now one last thing, you can actually apply the rotation to a point. So you just create any point in space and you ask how would this rotation rotate this point. Then you call apply rotation and it gives you a new point after this rotation has rotated that point. Now that can be useful for something later, but for now let's leave it at this. And next we will look how to combine rotation and how to rotate a rotation. It will be really fun. So for now, thanks for watching. And oh, I would almost forget. Last time I promised you that I would show you how to make the car turn around like this. So let's do that quickly. So first, let's save the angle at which the car is currently at, and let's also make a new variable angle speed. So the car would turn at this much radians per tick as long as you hold the key. So if you hold the A key and you are going forward, you want to increase the angle because you are turning left. But if you go backwards, you are actually turning right, but going backwards. So it looks like this. So if I hold the A key and hold W, it goes like this. But if I hold S, it goes like this. So it is realistic in the way that if you are turning right and go back and forth, I mean turning left and go back and forth, this is how it looks. So that's why you need to decide whether or not you go forward or backwards and switch it accordingly. And then after the angle is adjusted, you just create an Euler rotation by this angle. So again, this is just like this model here. So the angle tells you how much you need to rotate it to the left. So it's pretty simple. And then, oh, this is a nice trick. So how do I move in the direction of the car? Now I could use the usual, just get the speed, get the cosine of this angle and add it to x, and get the speed, get the sine of the angle and add it to y. So that is the usual way of doing it. But I wanted to show you something different. So what I did instead is I take the vector that goes speed units in the x direction. Then I apply the rotation of the car to that vector. So since the x direction is forward, this is like going forward x direction, I mean speed units. But this will make it so that this vector is now rotated the same as the car. So now the vector is what I need to add to the car's position to make it go forward. So how do I do that? Well, I use the current position, which is xy0, and then I use add 3, which again just adds 3 vectors, so it adds this vector together with this vector, and I get a new vector xyz. Now I don't care about the z coordinate, so I throw it away, and I save the y and x. And this will make the car move. I thought this it was a fun way of using this function instead of using the boring sine and cosine as usual. And of course, if you are going backwards, you want to negate the speed variable, so it moves in the opposite direction. So that's how you make the car move. And I believe that's all for today. So yeah, just yeah, this is pretty obvious things. So thanks for watching and see you next time. Bye.